Welcome to those who are here live to our second webinar in this fall webinar series. Today, we're going to be talking about hop creep. What is that? What do we mean by that? Why is it a problem? Why is it a problem in your brewing? And what connections does yeast have with hop creep? Because we think of this as a problem specific to dry hopping or hops, but it actually is deeply connected with yeast, and by looking at yeast management, we can actually, as well as upstream in our brewing process, we can get rid of a lot of hop creep problems, or at least make it a little bit less bad. So let's jump into it. Let me just find my slides here. Hide myself a little bit here. Okay. Yep. So we're going to be talking about yeast versus hop creep, mitigation, and control. So if you are watching live, make sure to let us know in the chat who you are, where you're from, and what you're curious about learning about today. And if you're watching on YouTube, then thanks for checking us out. You can always ask questions in the comments, and we'll do our best to answer them. And you can always make sure to check out our other YouTube videos as well. We're trying to do everything we can to provide the best yeast and fermentation knowledge for brewers. Let's jump into it. What will we cover? What is hop creep? I've been playing around with those AI image generators, and I told it to make a hop creep in a brewery, and this is what it did. It actually made a character, which I think is pretty cool. So that's the hop creep. What is hop creep? Why is it a problem? What are hop derived enzymes? How is this problem in brewing caused? Why has this become a problem more recently in the beer industry? And then also, how does yeast impact it? How does yeast health impact hop creep, both in terms of the severity and the duration? And then also, what flavor issues might I get downstream as a result of hop creep? And how do I fix them? It's all super, super relevant. If you've made a dry hopped beer that was beautiful until it, finished dry hopping, or even like after a few days in the can and then just became a diacetyl bomb, this is probably what happened. You probably got a little hop creep re-fermentation that put diacetyl in your beer. So we're going to talk about how to prevent that, because no one wants that. So yeah, I had a lot of fun with the image generators here. There's our hop creep. What is hop creep? Hop creep, as we define it, is a phenomenon where dry hop beers, especially those that have high hopping rates, experience a secondary fermentation or a re-fermentation. So, and this is a result of the release of fermentable sugars from those added hops, whether that's directly from the hops or whether that's from enzymes. It can often be a bit of both. We'll get into the science of that. And this unintended fermentation, it can lead to a range of issues. It can lead to, first of all, overcarbonation. You can get beer that is more carbonated than you want it to be, or maybe even exploding in the cans. It can cause overproduction of alcohol or over attenuation. So if you're trying to target a specific alcohol for the label that's on your can, it can be a real problem. It can also lead to diacetyl formation, so off flavor. It can extend your fermentation time, and we've seen hop creep basically double or triple the tank residency time if it's not taken care of. So on a commercial standpoint, it can be a huge problem. If you can solve it, you can often cut your tank residency time in half. So that's pretty significant, because at the end of the day, you're going to be able to get beer to market faster. You're going to be able to maximize the efficiency of your fermentation vessels. And yeah, the last thing we want is beer exploding on shelves. In addition to things like diastatic yeast, hop creep is a potential root cause of that problem. So what does it look like? I just wanted to provide one example. These are slightly different fermentations, but just to provide a bit of an illustration of what does hop creep look like. So the fermentation on the left, I would say, is a pretty normal fermentation. It's actually quite efficient, quite fast. You can see by 48 hours in, so by between 0 and 100 here, that's hours on the x-axis. It's mostly done fermenting. That's awesome. I mean, that's not going to be the case in every single brewery, every single style of beer. This is definitely an ale fermentation, but it's nice to see. It's nice to see the beer hit a pretty stable final gravity. In this case, around that 100-hour mark. So around 4 or 5 days in, we're hitting stable final gravity. If the yeast is well managed and we're at ale fermentation temps, that's not out of the ordinary. I know some people might be used to longer fermentation times. If you are, let's chat. We can help you. We can help you speed that up if that's of use to you. But on the right-hand side is what I would say is a fairly classic creep. And in fact, that's not even an extreme creep. It's fairly normal where you do see your bulk of your fermentation, once again, is done around the 48-hour mark. But you have an extended tail end of the fermentation. And that could be caused not only by hop creep, it could also be caused by just the types of fermentable sugars that are in your wort. And we've talked in previous videos about the different types of fermentable sugars and the order in which the yeast ferments them. But this is a classic example where you see the bulk of the fermentation is still done pretty fast, 2 or 3 days, but it really takes a while to get down to that final gravity. So if we look at that, it's sort of separated into 2 segments. We can see that primary fermentation, completing the bulk of the fermentation, hitting around 4 Plato, but then that beer is taking another 4 or 5 days, in this case, to trickle down to final gravity that's around 3 Plato. So this is very typical case of hop creep. I actually pulled the data from Grist Analytics, which is a data analytics platform. We've also got a brewery data deep dive that we just did last week. If you want to check that out, it's a lot of fun. It's a really cool platform. And just to show an example of hop creep here in the blue line, we've got a bunch of individual beer ferments there in the background as well. But this is what we're looking at. And it is a bit of an issue on the commercial brewing side because that beer isn't stable, right? You wouldn't be able to take that beer, crash it, proceed with packaging because it's not done fermenting. And it can actually be a lot more extreme than this. I actually picked a fairly, I would say, an okay example of hop creep. Like I think most of us would accept 4 or 5 days. That's okay, especially post dry hop. But I've seen in some cases that period of hop creep of that beer just sort of trickling down in terms of that final secondary fermentation. I've seen that take up to 10, 15 days. And that's where it really becomes a problem because especially if you're waiting for the beer to get through the fermentation to get through hop creep, and you've already dry hopped, like every day that beer is warm, you're potentially losing some of that dry hop aroma. So it can become a battle against time. And that's why a lot of folks do find it to be a problem. So what is the potential severity? Just to provide another illustration, there's been some really good research on this topic. So I'm trying to include some examples from the scientific literature when I can. But it's just show an example. There's 2 beers here where they basically forced this process by adding hops and yeast to a finished beer. And you can see that difference. So both in the blue line towards the very top where it creeps up to day 10, as well as that orange line, that can show the severity of what you can get. So when you're looking at hop creep, you're often getting a rise of about 0.5 to 1% alcohol. Or in terms of specific gravity drop, up to 2 Platos, or 8 gravity points if you're in specific gravity. So if that's the kind of gravity drop you're seeing towards the tail end of your ferment, especially post dry hopping, that would be explained by hop creep. There are other sources of over attenuation in beer that also could include things like diastatic yeast cross contamination. But this is pretty typical for hop creep. Tends to be pretty slow, especially if it's post package, because there's not much yeast in that beer at that point, and tends to not be as extreme as say a diastatic yeast cross contamination would be, where you might actually see it, creep up by maybe 2% alcohol and really over attenuate. So this is a really good illustration of what does a beer look like without hop creep versus with it. So how does it happen? We'll break it down step by step. So hop creep is caused by dry hopping. So hops have both some degree of fermentable sugars. They do contain some fermentable sugars, and they also contain enzymes. And that's often the source of the most extreme hop creep that we've seen in the literature. So those enzymes from the hops, and this can include all sorts of different enzymes. Hops do have alpha amylase, beta amylase, as well as amyloglucosidase. So it has a wide range of essentially starch degrading enzymes that can be present in the hops. And these enzymes can break down unfermentable sugars like dextrins and into simpler sugars that are fermentable. So one enzyme that's particularly pesky here is an amyloglucosidase. What that enzyme does, it's exactly the same as the enzyme in diastatic yeast. It trims the glucose off the end of that dextrin. So every time it does that, it's releasing a glucose that's now fermentable by the yeast. So you can have this, if there's weak enzyme activity over time and weak yeast activity over time, you can have a pretty prolonged fermentation. And that's what's often going on during hop creep. And that's what it causes, a long secondary fermentation. So the yeast that's left in the beer, it's often, yeast that's kind of tired out, worn out from the fermentation process. It's usually not the healthiest yeast, and it's now got to deal with more enzymes and more sugars to ferment. So it will ferment those newly available sugars, but if the yeast isn't healthy, it'll do it slowly. So over time, that yeast will ferment slowly and produce more alcohol and more carbon dioxide. So you can see, at least in the literature, what we've seen is anywhere from 0.5 to 2 Plato during hop creep. I would say in general, it's around 1 Plato or 4 gravity points. Just some examples on the right of glucose actually being released via hop enzymes as well as maltose. So just showing the activity of those hop-derived enzymes on breaking down some of those unfermentable beer sugars into fermentable sugars, which is ultimately how we end up getting hop creep. Here's another really great illustration, I think, just to show like what is the difference. And this is, one of the examples that helps prove that hop creep is caused by a combination of yeast and hops. So you can see here, if they just add hops at the top, no change in gravity if there's no active yeast. If they don't add anything, it's just, beer, sterile beer, nothing happens, makes sense. If they just add yeast, in this case, they probably added some fresh yeast to finished beer. Maybe that finished beer had a little bit of fermentable sugar left in it. Maybe the yeast that was used to ferment that original batch of beer was a little tired. So you see that very slight gravity drop, but it's still only about 0.3 degrees Plato. And then when you add the hops and the yeast, so you've got the hops that are providing enzymes and the yeast that's going to ferment those fermentable sugars released by the enzymes, that's when you get the creep. And this is a great example. You can see it, in this case, it's really coming down over the course of, I think this is in packaged beer, but coming down over the course of 40 days. And that's where this can be a real problem if it's not dealt with before the beer is packaged, because you get this prolonged secondary fermentation, which can cause, issues like diacetyl showing up in the beer well after it's been packaged. Alrighty. Hopefully that's clear. So just to illustrate further, like what are the implications of adding hop-derived enzymes to your beer? This is an example of what's going on. So hop creep will take those unfermentables. So we talked about dextrins, and it'll break them down potentially into fermentables. So one example that we can highlight is a sugar called maltotetrose. So that's I would say is like an almost fermentable sugar. Yeast won't ferment it, but it's one step away. So if you take an amyloglucosidase enzyme, whether that's from diastatic yeast or that's from hops, and add that to the beer, that enzyme will act on that sugar chain. It'll break the glucose off the end, and now all of a sudden, from a 4-sugar unfermentable chain, you now have glucose, which is fermentable, and maltotriose, which is also fermentable by beer yeasts. So all of a sudden, if you've got a sugar, and you can often have a fair bit of maltotetrose in a beer, in a finished beer or a wort. All of a sudden, you're taking all of that and you're breaking it down, and it's all fully fermentable for many yeast strains. So that's how we can get that pretty significant drop in gravity over time with hop creep. So big problem. Before we get into that, I did want to talk a little bit about, why is this more of an issue recently? And part of it is just the way that hop processing has changed. So hops are typically kilned as part of the processing of, making effectively shelf-stable dried hops. They go through a kilning process, but because of the change in trends and desire for aroma in the industry, kilning temperatures have trended towards happening cooler. And so you effectively have less thermal processing of the hops, especially when you look at aroma hops, and especially when you look at like Pacific Northwest aroma hops that are being used to make heavily dry hop beers. Those kilning temps have gone down, which then means that there's potential for more retention of enzymes or even microbes in those dry hops. So it's a bit of a trade-off, right? In return for getting more intense aroma, more intense flavor, we're also increasing the risk for hop creep, for example, causing some downstream challenges with the beer, causing this extended secondary fermentation. But there's also some other factors that control hop creep that I want to talk about, because I think some of this, many people understand what I've already just gone through, but there's actually some other process controls that you can put in place in the brewery to reduce your hop creep. And so if you reduce the degree of your hop creep, you can ultimately make it less of a problem. So one that I don't see talked about very much is your actual wort pH, and especially your mash pH. So mash pH actually does impact the activity of your starch degrading enzymes, so your alpha beta amylase from your malt. It actually has a pretty significant effect. So this graph from Braukaiser is a great example where you can see on the low end of the pH or the high end of the pH, the resulting beer actually has lower attenuation. So here's an example of other factors, other variables being controlled, and the mash pH impacting that attenuation, that degree of fermentation in the resulting beer. And considering that we're using enzymes to break down starches into fermentable sugars and dextrins, if that process is not efficient, then we might end up resulting in a wort that is rich in some of those almost fermentable or barely fermentable sugars, like maltotetrose, that, like I said, is just one step away from being fully fermentable. So that's one thing to keep in mind, and making sure that your pH is ideally in that optimum range during the mash, which tends to be around 5.3 to 5.5. I have seen people playing around a lot with pH in hazy IPAs or New England IPAs, or even West Coast IPAs in general. There's a lot of different schools of thought out there, but some people do acidify their mash or acidify their wort prior to fermentation. Some people don't, and target a higher pH. But what I would suggest here is that even if you are acidifying for flavor or some other reason downstream, there is some some people swear by adjusting pH to control haze. There's no evidence for that, but again, there's a lot of science that still hasn't been done. But what I would suggest here is don't mess around with the pH in your mash. Just keep that consistent. And if you do have to adjust your pH, I would do that after the mash process is done. So you could do that either pre-boil or post-boil, for example. And then moving on, we can also look at mash temperature. So this is a little bit more well-known. Mash temperature also impacts our fermentability, right? So you can see some examples here of both time and temperature. So I should also add time as a variable. In general, a hotter mash temp will result in a less fermentable wort. There are some exceptions to that rule, but that's something to keep in mind as well, that, I have seen some cases of hazy IPAs being made with a pretty high mash temperature and a short mash time. That can often mean that you're making a less fermentable wort. It also might be a less fermentable wort that is, there's been some enzyme activity, so there's probably a higher rate of those almost fermentable sugars in there. So something to watch out for there is if there's some variability in your mash time, your mash temperature, that can also cause some variability in hop creep. And the way to dial this in is to, I would look to controlling attenuation through yeast strain selection, as well as just setting on a consistent time and temperature for the mashing so that it's a known quantity. I've seen folks looking to control that sort of final gravity juiciness of the beer through, a high mash temp, short time. What that can do is create a lot of those barely fermentables, or yeah, uh, barely fermentable sugars, which again, when those hop creep enzymes get to them, that can cause some significant problems. And that's if you're getting like a really big hop creep, more than one Plato, that's probably what's going on. So you might ask, how do I avoid hop creep entirely? There are some options. There's nothing perfect, though. There's always a trade-off. One option out there is basically preheating the hops and inactivating the enzymes. This is a technique that's out there called dip hopping. You can look into that method, and that process of basically heating the hops before the dry hops are added to the tank will inactivate those enzymes and reduce the risk of hop creep significantly. However, the trade-off there is that you are thermally processing the hops, so you might lose some aroma, right? Heat will drive off some of those delicate aromas over time. One thing to highlight that just keeps getting better and better, and it keeps being more options out there, is advanced hop products. There's a lot of cool products out there from a number of different hop product producers, that allow you to add hop flavor and hop aroma without actually adding the hop vegetal matter to your beer. So I would check that out too. There's one called Spectrum from Haas there, but there's a number of other options. Like that's basically an extract designed to replace or supplement dry hopping. So if you can replace some of your dry hops with an extract like that, an advanced hop product, then that can reduce your degree of hop creep, which is a great option. It can also boost your yields because you will lose some beer to the dry hops. So I think those are pretty cool products that can really help you as a brewer. Another option is just go back to the old school way and dry hop post ferment, post crash. A lot of folks have actually shifted to doing this. This was the old way of making IPAs. Ferment out your beer, let it finish, soft crash, usually at about 15, 16 C, so 60 Fahrenheit. At that point, it's a great point to crop your yeast and save it for the next batch, and then dry hop. When the yeast has been crashed out and harvested, then you're going to get a lot less hop creep, especially if there's very, very little yeast going into the package later on. However, this can still cause some issues if the beer ends up getting warm stored, for example, and the beer isn't 100% removed. So if that beer isn't filtered, which most IPAs are not filtered these days, you're going to run into some issues potentially down the road, because you're still got some hop enzymes in solution. You still got some yeast. You might still have hop creep as a problem. So another option is also just dry hopping early. And this is one benefit of that mid-fermentation dry hop, is it does help you get through the hop creep faster. Then we get into the off flavors. So what's another reason besides efficiency that we would want to avoid hop creep? And that's off flavors. So number one issue with hop creep is diacetyl. So why does diacetyl happen with hop creep? Typically because there's poor yeast health at the tail end of the ferment. That yeast has already done most of the hard work that it thought it had to do, and all of a sudden you're throwing it a little bit more fermentable sugar. So the yeast is a little confused and is basically going to have to struggle through the last little bit of that fermentation, especially if nutrients are limiting. So if there isn't enough amino acids at the tail of the ferment, keep in mind that diacetyl is made by the yeast having to synthesize valine, which is an amino acid. If it doesn't have that, it's going to have to make valine, which puts it at risk of producing more diacetyl in your beer. And then there's also some of the upstream root causes of diacetyl to think about as well. So if the yeast is underpitched or it doesn't get enough oxygen, and oxygen is also a key yeast nutrient, you're going to run the more risk of diacetyl. In addition to amino acids and oxygen, zinc is also relevant here too. So zinc can really help yeast, especially in that tail end of the fermentation, help it tolerate the alcohol in its environment and get through that hop creep or that secondary fermentation. So if it isn't controlled, you're going to end up with a butter-like flavor, and you really don't want diacetyl in a dry hopped beer. Diacetyl tends to mask some of the positive characteristics of hop aroma. So you really don't want it in aroma hop forward beer. So how do you control it? Make sure your yeast is healthy. If there's one, take home of every single Escarpment Labs video, it's probably make sure your yeast is healthy, and we'll try to show you how to do that. And then there are some other options you can use too. So ALDC is becoming increasingly popular. It's an enzyme that you can add to your beer. You can add it to your wort before fermentation. You can also add it when you add your dry hops as well. So which is a good strategy in the case of hop creep, because ALDC basically should be added whenever there's any risk of forming the diacetyl precursor, alpha-acetolactate. So in the case of a dry hop beer, if you're using ALDC, I would recommend using it both at the start of the ferment and also adding it when you add your dry hops. That will maximize the efficacy of the ALDC enzyme. And what it does is it basically skips a step of the yeast having to manage diacetyl and reduce it into acetoin, which is a lot less flavor active. It just skips that step, converts that acetolactate, which is the diacetyl precursor, converts it right over to acetoin, so you don't have to worry about it. So that's another great option. Another off flavor that you'll run into with dry hop beers and hop creep is acetaldehyde. So acetaldehyde is caused by the yeast, once again, not having enough resources to complete fermentation. So in this case, acetaldehyde is actually a precursor to alcohol production. It's an intermediate step between sugars and alcohol. So if the yeast doesn't have the resources it needs to fully ferment those sugars into alcohol, you end up with some acetaldehyde in the beer, and that causes an off flavor. It's an apple-like off flavor in the beer. So in this case, we're introducing a secondary fermentation. And if we're also running on kind of tired yeast, we can have a situation where the yeast doesn't fully finish that secondary fermentation in the hop creep and leaves acetaldehyde behind. And once again, it's a big issue for dry hop beers because in my experience, that acetaldehyde can change or mask the aroma of dry hops. It can often make dry hop beers taste or smell like cantaloupe in an unpleasant way. So it's definitely something to watch out for. And it's, again, the root cause is often just yeast management, yeast health. Zinc plays a huge role here because zinc is important in the actual process of turning acetaldehyde into ethanol. As is oxygen. Make sure that yeast has enough food with FAN as well. So controlling it. I'm going to sound like a broken record, but make sure your yeast has enough nutrition for your specific yeast and your specific wort. Some yeasts need more than others, and that's really important to watch for. Make sure the yeast has enough zinc. That's going to help it convert acetaldehyde into alcohol. Make sure it has enough oxygen so that it grows properly. And also make sure to count your yeast. One root cause of acetaldehyde is overpitching, which is tempting to do with these beers. Throw more yeast at the ferment and get it through faster. But it doesn't always work that way, because if you chronically overpitch, you end up with a yeast population that's older on average than it should be, because it will always go through a limited amount of growth cycles. So that's the reason to do yeast counting and manage your pitch rates, is that you'll end up with the right population structure in your yeast so that you don't have too many super, super old cells in there. So I think yeast management plays a really, really big role in controlling hop creep. If you have poor yeast health, you will get a longer hop creep. And that's, if we see some of those hop creeps that are taking, 8, 9, 10, 14 days, usually the root cause is not the specific type of hops. It is the health of the yeast that went into that fermentation. Controlling FAN, free amino nitrogen, and controlling zinc as yeast nutrients tends to have the biggest impact. And having enough nutrition in your wort helps to ensure that the yeast, when it's at the end of the ferment and it's faced with the new sugars released by those hop-derived enzymes, make sure that yeast is healthy enough to keep fermenting. And it's not just us saying this. I've heard some really, reputable brewers like Vinny Trelurzo, Russian River, a few others talking about, process improvements in their breweries. And one thing that I've heard come up with a number of them is that they started adjusting how much zinc they add to the ferment and when they add it. One common way to add zinc is to put it in the brew house, into the wort when it's hot. It doesn't actually work very well in practice because that zinc will chelate or precipitate with your trub. And so oftentimes if you're adding zinc hot side, it doesn't actually get into the wort in a very efficient manner. So what I have heard stories from a few famous brewers like Vinny saying, we switched to adding our zinc to the fermenter, basically made a sterile solution, and we put in a little shot of zinc to the fermenter, and all of a sudden the hop creep is significantly decreased. So that's really, really cool to hear. And I would highly recommend. And if you're looking for an option to get adequate nutrition, I do highly recommend our Yeast Lightning, which does have some bioavailable zinc. It does have some FAN. It does have other micronutrients that will help the yeast with its journey through fermentation. And another thing to highlight is that oxygenation also plays a role. If the yeast doesn't get enough oxygen for what it needs, you won't get enough yeast growth. And that means that you're going to have less yeasts doing the same amount of work. So they're going to get tired out, and you might end up with poor yeast health at the end of the ferment and cause a longer or extended hop creep. So how do we vanquish the hop creep? We can control fermentability by keeping our mash pH, temperature, and also mash time consistent. I think that these are actually some of the most important factors in controlling hop creep, and we often don't, because it's like a fermentation dry hopping issue, we often don't even think about the brew house, but the problem starts there. We're controlling the breakdown of sugars and dextrins in the brew house. So we can often not necessarily solve the problem, but we can reduce the problem and mitigate it in the brew house by controlling our mash pH, controlling our temperature, controlling our time, and designing a mashing process that reduces the risks of hop creep. And then when we get to the yeast, we can select a yeast that's going to have a attenuation profile after the hop creep that's compatible with the beers that we're brewing. So if you're trying to make a beer that's like super, super high final gravity, like with some residual sweetness, I know that is popular. You can select a yeast that's intended for that purpose. So Hydra is a great example from us. It's super compatible with hazy IPAs. Foggy London is a very famous yeast for that application as well, and it does have lower than average attenuation, which then means that when that beer goes through the hop creep, you land in a good place. But you don't need to select a low attenuating yeast. You can control that in the brew house as well, and that opens up a lot of other possibilities with yeast strains. So whether that's a yeast like Vermont or some of the new ones like Pomona and Elysium, you've got a lot of options with dry hop beers. Number 2 is make sure the yeast has enough nutrients, especially zinc. Really, really, really important in downstream fermentation control, because hop creep is, you're basically forcing the yeast to go through another stressful fermentation. If it has what it needs, it's going to get through it faster without it as much stress. So you're going to get a faster turnaround on the beer, and you're also going to get less risk of off flavors. If you are dry hopping mid-ferment, you can consider, or even towards the tail end of the ferment, you could consider doing part of the dry hop earlier in the process. That is a pretty tried and true way to help the yeast get through the impact of those hop enzymes faster. However, there are some trade-offs. So dry hopping really, really early in the process was shown by omega yeast to decrease haze. Like if you're dry hopping, at cast out or a day in, for example. So that's something to watch out for. It also, adds a step to your process, but that's a pretty common approach. Although, keep in mind that if you're dry hopping mid-fermentation, it does make the yeast management a lot harder. So in that scenario, I would recommend, if you're using a certain strain for your IPA, hazy or otherwise, try to have another beer that isn't dry hopped that's made with that yeast, like a blonde ale or something like that you can use to basically make yeast for your hazy IPAs. As a seller of yeast, it's great for the bottom line if breweries are buying fresh yeast every time, but I know that that's not going to be sustainable long term. in the industry. So, hoping to inspire some different ways of thinking about yeast management. And that brings us to the end. There's a lot of other resources out there on hop creep that you can check out. So I didn't want to like step on anyone's toes too much. I really wanted to focus on, um, the connection between yeast and hop creep as much as possible here. But if you want to learn more, you can check out our knowledge base and our YouTube. And I did also want to highlight an article on our blog that was written actually by Bryn from Grist Analytics about dry hop creep. So definitely check that one out because it's actually got a bunch of links to other resources, including stuff from some of the hop scientists that have been doing really, really great work on this topic and helping us understand it better. So make sure to check that out. There's a lot of great resources. And if you had a good time here, if you enjoyed this video, make sure to check out our other videos and also tune in to our upcoming webinars. So to close out this series, we're going to be talking about foam. One of my favorite topics. Lots of people struggle with getting the beer foam they're looking for. So we're going to try to break down how to not break down your foam. We're going to be talking about haze as well. So whether you want your hazy beers to be hazy or your clear beers to be clear, there's a lot of knowledge and information to share there. And we're also going to be trying to tie all these topics together and talk about the modern IPA. Where the heck is the IPA going? What tools do we have available to us? And how is that going to change the future of the most popular style of craft beer? And that's it for us for today. Happy to answer any questions that come up. If you're watching live, you want to throw anything in the chat, I'll stick around and answer your questions. Otherwise, if you're watching on YouTube, make sure to leave a comment if you've got any questions, or even just to say like, hey, thanks for making the videos. That's what inspires us to keep going, and keep going we shall. So even after this series, you can look forward to some content from us about lager fermentation, lager production as we get into the winter. Yeah, I saw the comment from Brent saying there's a Brew Lab podcast talking about hop kiln temps and impact on hop creep. Yeah, there's lots of research that's been done on that. I know it's been a topic of study for both for groups at Oregon State. So Tom Shellhammer's lab's done a bunch of work. I've also seen some research coming out of Glenn Fox's group at UC Davis. Lots of great work happening in this specific topic, and even now researchers are starting to dive into like how do specific yeast strains interact with hop creep. Are there correlations with certain varieties of hops or processing methods, including the kiln temp? I've seen some. I don't know if it's been published in papers, but I've seen some pretty cool research on even looking at what's the incidence of hop creep or enzyme content based on where the hops are grown. Is Mosaic grown in Idaho different from Mosaic grown in Oregon or something like that? So there's a lot of interesting research that's happening because it is a pretty major problem, considering that a lot of the most popular beers in the craft beer industry are dry hopped and are increasingly dry hopped at a higher rate, right? So we got a few more questions here. So Aslan asks, hey buddy, would using a larger volume of dextrin malt or high protein malts like raw wheat be a better way to chase body than high short mash temps for some of these beers? Yeah, if there's a way for you to get body from things that aren't sugars, if you can get body from protein, for example, then that is going to work better than getting body from residual sugar in this case. So that is something to consider. If you've got something that would add some, or even that adds like a stable dextrin content. So I actually don't know this to be true, but I speculate that some dextrin malts might help you there if that dextrin profile is more locked in. That might be something to look at. Again, you've got yeast selection as an option too. And I love the idea of playing around with different grains to actually chase body. Like there are some brewers that will use raw wheat, flaked wheat, for example, in these kinds of beers. Anything that'll adjust body. Oats are an example there too, where you have different types of polysaccharides or proteins that come out that might impact the body of the beer. So that's another option that you have to play around with versus just, kind of dancing on the knife's edge with those barely fermentable sugars. So I've got another one from Evan here, Evan Hook. Seems like there aren't many options, but I'm wondering if you have any ideas for allowing a yeast harvest while also dry hopping warm to encourage creep and cleanup to occur quickly. Yeah, that's like the $1,000,000 question. Aside from coming up with some kind of device to like physically separate the yeast from the dry hops, which is in theory possible. I don't know if anyone's actually done that in practice. It's really, really hard because most yeast strains aren't going to like flock out appreciably by the time you're at mid ferment. And even the ones that do, you might see some negative impacts of like bottom cropping or top cropping a yeast strain early in the process. You might select for, aggressively top or bottom cropping cells in that population. So it might actually then change it over time. Typically if you select for flocculation in yeast, you're also going to select against attenuation. So like oftentimes if you select for the very bottom of the yeast, over time you're going to change the attenuation of that just because it's yeast that's like flocking out and not fermenting as aggressively. But there are other strategies. Like there is a presentation out there that has been shared with master brewers at a few different conferences about a method for top cropping in closed tanks. So basically like overfilling the tank and letting the yeast blow out, which that requires a lot of work to dial in, but it can be done. And that is a way to get a yeast harvest. And then, even while dry hopping warm or early. I will say like there are some high flocculent strains that work in this context. So is there a high flocculent strain that is also super haze positive? Not really to my knowledge. So that's something to work on. Maybe some of the Kveiks would fall into that. You could definitely look at like Laerdal or Evergarden Kveik are actually great options in that category. But if you have a yeast that's highly flocculent and you're going to be able to get like a significant amount of the population settled to the bottom of the tank by the time you're dry hopping, you might be able to make that work. So I wouldn't really try that with like a Foggy London 3 type strain, but it certainly could be done with, I'm trying to think of some examples, like a Laerdal Kveik. If you're making like a West Coast, your English 2 style strain could work pretty well. Newer strains, Elysium, not haze positive. You can make hazy beers with it, just like any other non-haze positive strain. It's not just yeast. Elysium's great because it's highly flocculent, so you'd be able to get it out there and repitch. So that's an option as well. Unfortunately, the most popular yeast for dry hopped beers, actually both of them, I would say, the Cali Chico strain and the Foggy London, neither is super flocculent. So then that makes it really, really hard to get the yeast out before dry hopping. So hopefully there's some solutions to that problem as time goes on, because it is a major challenge for the industry, I would say. All right, I think we're pretty much out of questions, so we're going to wrap this one up, and I'm looking forward to seeing you next week to talk about one of my favorite topics, which is foam. And we're going to whip the meringue. We're going to make some lovely foam and help you do it. All right, cheers.